All right, let's keep this rolling. So on letter C, we have sine of theta over 1 plus cosine theta plus cosine over sine. So we've got two fractions being added together. So knowing what we know about adding and subtracting fractions, we got to get a common denominator. So to get a common denominator, the simplest way, even if it's not always the most reduced, is to multiply one fraction by the denominator of the other fraction. In other words, we're going to multiply the left fraction by the sine of theta both on top and on bottom. And then for the other fraction, we're going to multiply by 1 plus cosine of theta in the numerator and in the denominator. Now, for the first fraction, sine times sine is going to give us sine squared. And then the denominator, let's actually, for now, let's just leave it as sine of theta times 1 plus cosine theta. For the other fraction, sorry, I'm off the screen. We have cosine times 1 plus cosine. Well, when we distribute cosine, we do cosine times 1 is cosine. Then cosine times cosine is cosine squared of theta. And then, similar to the previous one, we're going to leave the fraction as sine of theta, sorry, the denominator as sine of theta times 1 plus cosine of theta. Now that we have a common denominator, we can add these two fractions together. We're going to do sine squared of theta plus cosine of theta plus cosine squared of theta all over sine of theta times 1 plus cosine of theta. Now that numerator, I'm going to reorganize it a little bit. So that way we have a bunch of addition up top. And so that way, and remember, addition is commutative. So in other words, we can move the sine squared and cosine squared next to each other. And we'll just have plus cosine on the end. All over sine of theta times, goodness gracious, times 1 plus cosine of theta. Now, sine squared plus cosine squared, that we've already used this a couple times, that's just 1. So that's a Pythagorean identity. So we end up with 1 plus cosine of theta over sine of theta times 1 plus cosine of theta. I feel like I just repeated myself, and that's because I kind of did. Oops, sorry. So 1 plus cosine can cancel out. Remember, when we cancel those out, we end up with just 1 on top and 1 on bottom. So our numerator is 1 over sine times 1 is just sine of theta. Now, 1 over sine of theta, we know, is cosecant of theta. So this all simplifies down to the cosecant of theta. For letter D, I'm going to go back to a piece of advice I said on, I believe it was letter B. If you can get things in terms of sine and cosine, do it. So for example, secant squared would be the same as 1 over cosine squared of x. So that's just a reciprocal identity. Now similarly, well not super similarly, but 1 minus sine squared, we can convert that into cosine squared of x. So that is using a Pythagorean identity. Now we end up with 1 over cosine squared times cosine squared. You can even put that over 1. The cosine squareds cancel out. This whole thing simplifies down to just a grand total of 1. It's crazy how sometimes the more complicated things can simplify down pretty nicely.